Okay, right. We are now going to attend to an example. The example, it reads by stating a gas whose original pressure, let's just do this, a gas whose original pressure, volume and temperature was respectively is compressed to a new pressure and a new temperature. Okay, that already tells us everything we need to know. Okay, right. So how are we going to approach this? It's actually very simple. A gas whose original pressure, volume and temperature, so we are going to write that down. Pressure, volume and temperature, P1, V1, T1, because it's original. Okay, the pressure was 140 kilonewton per meter squared. Okay, and then also the volume, it was 0.1 cubic meters, and then the temperature, it's 25 degrees Celsius. Okay, right. And then right, what's happening here is then they say it is compressed to a new pressure, that's P2, that's V2, and then that's T2. T2 is 60 degrees Celsius. Okay, T2, and then P2, it is 700 kilonewton per meter squared, and then find the new volume. That means the volume here, it's unknown. Okay, the volume here, it is unknown. Okay, so how are we going to proceed? Okay, it's actually very simple. We remember, okay, when you normally have a problem like this, first of all, your temperatures, you have to convert them to Kelvin. Okay, so let's take T1. T1, it is equal to what? 25 degrees Celsius. How are we going to convert this to Kelvin? It's actually very simple. Now, what we are going to do is, we are going to say 0 degrees Celsius equal 273 Kelvin. Okay, now, what does that mean? For me to go from 0 to 25, I need to add 25. So I add 25 on both sides. So when I add 25, I get 25 degrees Celsius. Equally so, 25 plus 273, that is equal to 298. The unit for that is Kelvin. So that's our new value moving forward. Equally so for T2, it is equal to what? 60 degrees Celsius. Right, we start off by saying 0 degrees Celsius is equal to 273 Kelvin. Simply put, we are going to add 60 here. We are also going to add 60 over there. And then 0 plus 60, it is equals to 60 degrees Celsius, which is what we have. And then over here, we are going to have 333 Kelvin. And this is actually the one that we are looking for. So long story short, our 25 degrees Celsius, it is actually equal to 298 Kelvin. Our 60 degrees Celsius, it is actually equal to 333 Kelvin. Okay, now, what does that mean? What that simply means is now we can proceed. So how are we going to proceed? Okay, we are going to proceed by stating the following. PVT is equal to PVT. Right, what does that mean? What that simply means is the following. PV1, V1, T1, P2, 2. Okay, right. And then also, what are we looking for? We are looking for V2 equals to. Okay, right. So in order for us to get V2, we are going to say times T2 divided by P2. And then obviously if we do this on the right hand side, now we should also do that on the left hand side. So it's times T2 divided by P2. Okay, right? So when we do that, what is going to happen? What's going to happen is this then gets cancelled, that gets cancelled, and then essentially speaking, our V2 is equal to what? Our V2, it is equal to T2 P1 V1 over P2 times T1. Okay, so now our V2 is equal to, what is T2? T2 is equal to 333 Kelvin times our P1, it is 140 kilonewton per meter squared, and then our V1, it is 0.1 cubic meters, and that divided by our P2, which is 700 kilonewton per meter squared, multiplied our T1, which is 298 Kelvin. Okay, now just as an add-on, I'm going to add on the units. For T2, nah, the units, it's actually Kelvin. Okay, for P1, the units is actually kilo newton per meter squared. Okay, and then for V1, the units is actually equal to meter cubed. Okay, and then also for P2, nah, for P2, it's actually kilonewton, okay, per meter squared. Okay, and then also for T1, it's actually equal to Kelvin. Okay, now that's our units. So now we can do some cancellation. Remember, this isn't really necessary, but it's critical. The reason why I say it's critical is because this is how we realize that we end up with meter cubed, okay, which is the unit for volume. Okay, right? And then we'll now go and take a calculator. Okay, right, we are going to say 333 times 140 times 0.1, and that divided by 700 times 298, and that equates into, so our V2 according to this is equal to 0.022 blah 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 meter cubed. Okay, and then that is our answer.